Okay, for our first problem, we have an object that is launched at 19.6 meters per second from a 58.8 meter tall platform. The equation for the object's height, s at time t seconds after launch, is s of t is equal to negative 4.9 t squared plus 19.6 plus 58.8, where s is in meters. When does the object strike the ground? Okay, so first thing you need to know, okay, is this is kind of a standard, what we call position formula. So S is position. T is time. In this case, it's in seconds. Okay, so here, the general formula, if you've taken any type of physics, you'll know that this is negative g, the acceleration of gravity, divided by 2, I believe, or acceleration, we'll just call it acceleration. Then t squared plus what we call an initial velocity times t plus the initial position, we'll call that s naught. Okay, now if you haven't taken any physics, that's okay. You can still do the problem. Okay, you'll notice that I have a nice x, y, or t time position graph. So this is time, this is s position. Okay, so if we look at our equation here, we notice that we have a y-intercept of 58.8. Okay, so we're going to launch at 58.8 meters. Okay, it's going to travel up in a parabola, and it's eventually going to hit the ground at the bottom. So we want to find out what time it hits the ground. Okay, so how we do that is we're going to find the intercepts of this particular function. Okay, all right, so I have this particular equation, negative 4.9 t squared plus 19.6 t plus 58.8. Okay, so there's a couple different ways I can do this. Okay, I can, if I want to, what I can do is I can use Desmos, and I can just graph it in Desmos and find the x-intercepts that way. If I don't want to use Desmos, then I'm going to start leaning on quadratic formula. So t would be equal to negative b plus or minus b squared minus 4ac all over 2a. Okay, we're going to go ahead and plug in our values. Okay, remember that a, in this case, is negative 4.9, b is 19.6, c is 58.8. So we have negative 19.6 plus or minus 19.6 squared minus 4 times negative 4.9 times 58.8 all over 2 times a negative 4.9. Okay, now I am going to go over and get my calculator out, and we're going to pop this in a calculator and see what we get. So let's see here, negative 19.6 Okay, so let's see here. Negative 19.6 plus or minus 19.6 squared minus 4 times negative 4.9 times 58.8. Okay. Remember to take the square root of that eventually. Two times 4.9 negative 9.8. Okay, if we do that, we get 19.6 negative plus or minus 39.2 divided by negative 9.8, which gives us negative 2 and positive 6. Okay, so a negative time doesn't make sense, but a positive time does. So our object would hit the ground at 6 seconds. All right, that's your first problem. That's a motion problem. Now I can take this problem and also turn it on its head, and I can ask you for a maximum height too. Okay, you do that by finding the vertex of your parabola. Again, you can totally use Desmos, or you can use the formula for axis of symmetry. Okay, all right, next up is an area problem.